Right now, I'm going to do a couple of problems that have a few things in common. They're problems where it's really helpful to use a table, and you'll also notice that if you really think about it, these are essentially the same kind of problem. This question here is a question about a piggy bank with nickels, dimes, and quarters. Pretty common word problem type. She's got a bunch of quarters, dimes, nickels, and the problem with these problems is that nickels aren't worth as much as they like whatever your number of nickels is going to be different from the value of how much those nickels are worth. And that is sometimes difficult for people to deal with. Another problem where you can see that if you think about it, it's really like one of these piggy bank problems is here I've got at a movie theater's last show 245 tickets were sold. I've got adult tickets that cost $8, children's tickets that cost $5. So that means that however many children's tickets I have, the value of those children's tickets is going to be different from the number of children's tickets. So in that way, it's very similar to the piggy bank problem. And both these cases, or any problem where you have, like let's say for example, I have some animals that have 4 legs, and I have information about how many legs they have and how many animals there are. That's another case where I've got different values for how many animals there are and how many feet they have. They all fall in this same category. And in all these, coming up with a table is a great way to organize your information. So your first step, you got to come up with a let statement here. In this one, I've got a bunch of things that are floating around. It tells me if there's a total of $8 in the piggy bank, how many nickels does she have? My question at the end is a great place to start if I'm not sure what to do for a let statement. In this case, it's suggesting, well, I could go with nickels, right? In this case, it would actually be easier to start with dimes. You could do it with nickels, but it would be a little more work. The reason why it would be easier to start with dimes as your let statement is because if you look in the whole problem, especially in this sentence here, she has twice as many quarters as dimes and 8 fewer nickels than quarters, right? That all these things are built off of, like if I have a basic unit, it'll be dimes. Usually you can find this out by trial and error. So if you screw up early on in the problem, you're having trouble at step 2 writing expressions, maybe go back, try a different thing in your let statement, see if it makes things easier for you. To give you an example here, I'm just going to go ahead and say, let's say I read the question at the end. It says, how many nickels does she have? So say, all right, let me go with let n be the number of nickels. First off, in these money problems, notice I'm saying not just nickels, but number of nickels. The more specific you are in this, instead of just saying let n be nickels, the less likely you are to get confused as to whether you're talking about how many nickels you have or how much they're worth. And that's where these problems tend to trap you, so it's good to make that distinction. All right, if I say n is the number of nickels, then I say to myself, let me try and write an expression here for the number of quarters. It says there's 8 fewer nickels than quarters. Does that mean I should do n minus 8 or 8 minus n or 8 plus n? What should I do? Fewer feels like a minus, right? But if I'm stuck, I say to myself, let me plug in real numbers. Let's say I knew that there were 10 nickels. If there's 10 nickels and it says there are 8 fewer nickels than quarters, it's going to be pretty easy for me to think, well, that means there would be 18 quarters. And then I'd say, well, if n is the number of nickels, that means 10 is n, which would mean that this 18 would have to be n plus 8. So that's how I can tell myself n plus 8 is the number of quarters. Again, I'm not just saying n plus 8 is quarters, I'm saying n plus 8 is the number of quarters, because the value of quarters is going to be something else. Then it says she has twice as many quarters as dimes. If n is your let statement here, this is going to be okay. It just means she has twice as many quarters as dimes, right? If this is my number of quarters, and I'd say, well, if she has twice as many quarters as dimes, if you had 10 quarters, then I'd say she's got twice as many quarters as dimes. I can usually figure out how that means 5 dimes. What did I do to this 10 to turn into a 5? I divided by 2. So that means I would do n plus 8 divided by 2. Now this isn't impossible, but if you're throwing a division in here, it's just for a lot of you guys who aren't too comfortable with fractions, having n plus 8, oops, I screwed that up, n plus 8 divided by 2 as your number of dimes might make your equation a little bit harder to handle. I'm going to stick with it though. I want to just show you guys that if you had this, even though this is all right, this is fine, you can write a great equation, you can solve it fine. But if you're thinking, I want to minimize my chances of error, let's watch the same problem if I make my let statement, as I could if I wanted to. Let D equal number of dimes. If D is my number of dimes, then I could go back and say she has twice as many quarters as dimes. If she had 10 dimes, she has twice as many quarters and dimes. That would mean 20 quarters. What did I do to the 10 to get the 20? I just multiplied it by 2. So if D is my number of dimes, 2D would be my number of quarters. Right, this is me doing step 2 over again. You're coming up with the other expressions in the problem. And then 8 fewer nickels than quarters. Well, 8 fewer nickels than quarters. That's going to be this, minus 8. 2D minus 8 is my number of nickels. So both of these are legitimate setups here and here for this problem. Both of them are fine. If I do both of them properly, I'll get the right answer with both of them. I'll get the same answer with both of them. But for my money, this would make my life a little bit easier. I've got no fractions, right? I've got no divided by 2 over here. So if I see what's coming, I might try this. But let's just show you that even this one here isn't too difficult if I just stick to the rules of math. Where I really recommend that you come up with a table is, I'll show you, I already mentioned it's in problems like this. It's not an elaborate table with, 16 different headings or anything like that. It's just something where you've got 2 columns and, I could try and pretend I'm intentionally doing a terrible job in making this table, but I'm just blaming the software I'm using here. And then you've got just 2 rows, see, and like these boxes on the left, I'm just going to put labels in there, and 2 columns. Look at this terrible table I'm doing. It's still going to work great. So here, I forgot with this problem I'll need 3 lines because I've got nickels, dimes, and quarters. So I've got 3 lines. I've got here, I've just got nickels. And then my second row, I got dimes. And then the third row, quarters. And for for all 3 of these things, I'm going to put column here. I'm going to put the number of these coins is showing up in the 1 column. And I'm giving myself a second column for value of these, because that's going to be different. And then with these problems, that's always the big challenge. This is going to be different than this. If I have 1 nickel, it's not worth $1 or 1 cent. It's worth 5 cents. And that's different from how many nickels I have, right? I can already fill in everything in this column. I've got N as my number of nickels. I can put that in right away. I've got N plus 8 is my number of quarters. That I can put down here. And then the dimes is just N plus 8 divided by 2 in here. Now, to get the value of these, I have to say to myself, okay, if I actually knew how many nickels I had, if I had 10 nickels, what would the value of that be? 10 nickels? Well, that's worth 50 cents. That's not difficult to figure out. Then say to yourself, what did I do to go from the number 10 for the number of nickels to get to 50 cents? And you see, well, to go from 10 nickels to 50 cents, that number I multiplied by 5. That's what happened. So if N is there instead of 10, I would multiply that by 5 to get the value in cents. Now, some of you might have said, well, isn't a nickel, like here, it's talking about dollars here. It says $8. Couldn't I just make a nickel isn't a nickel in dollars? Isn't that $0.05? Yes, it is. But I prefer working in cents. I just find it's much easier. So in all these problems where it's talking about nickels, quarters, and dimes, I say to myself, I'm going to forget about the $8 right now and turn that into 800 cents for the whole problem. Because then I won't have any decimals in here. It'll just make it easier for me. So I'll keep that in mind for when we come up with our equation. All right, if I have some number of dimes, like let's say I had 10 dimes, then 10 dimes would be worth how many cents? Well, 10 dimes is $1. That's just 100 cents. I know that, and then I say to myself, well, how did I get from 10 dimes to 100? How did I get from this number 10 to this number 100? I multiplied by 10. So then I should do the same thing with this weird looking number of dimes. I just take it, say 10 times this whole thing, n plus 8 divided by 2. I'm just taking whatever the number of dimes is and multiplying it by 10. I'm taking whatever the number of quarters is and I'm multiplying it by 25, because that's what you do with quarters, right? See here I've got the number of all my coins. For the value of nickels, it's just 5 times that. The value of the dimes, just 10 times this. Value of the quarters, just 25 times this. And that table is the heart of solving a problem like this. Once I have all these values together in this problem, I'm ready to write my equation. I know that the value of all these added together should add up to $8. That's 800 cents. So my equation is just going to be me writing all three of these expressions added together. 5n plus 10 times n plus 8 divided by 2. And then plus 25 times n plus 8. And I make those equal to the 800. That comes from $8, right? 800 cents. So that's my equation right there. And then once I've got that taken care of, this table I'm still going to keep in my back pocket, but I'm just going to move it out of the way to give myself a little space. Now that I've got my equation here, again, this one, because the let statement I chose is a bit of a mess, but nothing we can't handle, right? I just got to follow the regular rules of simplification and BEDMAS. This here, the 5n, we're on step 4. The 5n is just the same, but then I'm going to simplify inside the brackets first, right? If you've got something inside brackets divided by 2, that's going to become n divided by 2 and 8 divided by 2. It's like each of them gets their own divided by 2. So I have n over 2 and 8 over 2, which is, we're going to simplify that to 4 in a second. And then I can already distribute 25 times n plus 8. That's going to become 25n plus 25 times 8, which is 200. And all this is equal to 800. So far, I've got this. Now I've got to distribute this 10 in here, right? So this is going to continue on. I still have 5n, and then I have 10 times n over 2. If you need to think of this as 10 over 1 times n over 2, right? Top times top, bottom times bottom. I have 10n over 2. And then my 8 over 2 here, that's just going to become a 4. So 10 times 4 is 40. Plus 25n plus 200 equals 800. And the thing with these equations is always each line is just an equivalent equation from the one before, looking a little bit better. Right now I'm still simplifying. I'm not trying to isolate n yet. Okay, this 10n over 2, remember 10n over 2, 10n divided by 2. I just divide the coefficient by the 2 here. That's going to become 5n. So I have 5n plus 5n plus 40 plus 25n plus 200 equals 800. And once I've gotten to this point, now I can add all my like terms together. 5n plus 25n gives me 35n. And then the 40 plus the 200 gives me 240. With these problems, they're actually really challenging for a lot of people, but when you get to your right answer, you can verify it pretty quickly, because if n ends up being some number that isn't a whole number, that isn't an integer, you've got to have done something wrong. So you can't have like 0.37 of a quarter, right? So that's one way to make sure that you've got it right. Next thing I would do here, I would subtract 240 from both sides of this equation. Doing the same thing to both sides. That's the main rule you got to keep. So now I'm left with 35n on one side, and on the other side, 800 minus 240 gives me 560. We're getting closer and closer to our answer. All I got to do now is divide both sides by 35. And once I do that, I have n all alone on this side. 560 divided by 35 gives me 16. So n is 16. Remember, n is the number of nickels. I'm going to verify at this point, make sure that everything is worked out all right. Ben is the number of nickels, and that's 16. And that means I've got